All right, welcome to part 2 of the experiment. So just to refresh your memory, during part 1 of the experiment, you saw how we placed 3 spots of red food dye evenly distributed throughout a tank of room temperature water. So there was a dot of red food dye on the left side, one on the right side, and one right in the center. The interesting part was how in the middle of that tank, we put a cup of boiling hot water underneath the tank, and we eventually saw that that hot water caused that middle dot to rise up and eventually disperse. This is because that hot water cup made the water and that red dot above it less dense than its surroundings, so it rose up to the top and it eventually dispersed as it began to cool down once it got away from that heat source. In this example, we're going to make things a little bit more complicated. We now have 2 cups of boiling hot water on the left side of the tank, and on the right side of the tank, we are going to add in 4 cubes of blue ice. So, you will see that I'm going to add in my red food dye above the 2 cups of hot water, the blue dyed ice on the other side, and we are going to see what happens. Food dye, and now gently putting my blue ice in. So I want you to watch and see, first of all, where that blue food dye is actually going. So if you look closely, you can see that that blue dye is literally coming off the ice and going down. It's traveling downwards and sinking to the bottom as that red dye is shooting up through the tank. And you're going to eventually see, if you look, there's going to be a major color change. You're going to see that whole bottom layer of the water tank is going to be blue and the whole top is going to be red. However, what's really interesting is how this whole process involves a simple form of heat transfer called convection, in which heat is transferred through fluids. So if you look, and this actually worked really well, you see the red food dye shooting up to the top, but once it interacts with the blue, it is going to get more dense because it's now colder, farther away from the heat source. So the red is now actually coming down as it cools off, which is awesome. And if you look on the other side, although it's a little bit hard to see, you'll see the blue ice water is pushing towards the left, which is going to eventually come into contact with that cup of hot water. And eventually, that blue water would become heated, and that should rise as well. So we'll watch this for a few more seconds. But essentially, this becomes a current because, again, the hot water cup makes the surrounding area less dense. It's going to rise. Once it gets far enough away, it is going to become more dense and it's going to sink. And so as that red water rose, the blue came in and tried to take its place, basically. Convection is super important, especially when we're thinking about atmospheric and oceanic processes. It is what allows ocean currents to happen, as well as what we know as wind. And again, if we're imagining that those cups of hot water are the sun, think about how this tank was heated unevenly. This is very similar to the fact that the Earth is also heated unevenly, unequally. And that is what leads to many of the weather and climate-related processes that we are studying. Oh, it looks so darn cool. All right. Thank you.